Okay, we're going to continue our lesson here on int roots. We started talking about this last time, and I think I had a knock on the door. But some of the concepts here is if n is odd, then it has one real int root. And so let's look at this, and I rewrote it here. So let's look at an example real quick here. I'll go ahead and show an example of the odd first. And just to keep things simple, we'll keep this visible for everyone to see. So if the n is odd, well, in this case, the n is odd because it's saying the n is a 3, right? So that's odd. So we'd write 3 here. And notice that the n is just the index. That's kind of easy to remember because n stands for index. And the a is what goes on the radicand. Okay, so we have the 3 on the outside. We have the negative 27 on the inside. And it is odd. So the rule when it's odd is what? Let's look at it again. If an integer is odd, then a has one real int root. So we have one real root because it's odd. Okay, well, let's see what that would be. So remember that a negative 3 to the third power, if we were going forward, would be a negative 27. So going in reverse, what would be the negative 27 to the third root? Well, it would also be a negative 3. And if we were to write that in factor form, let's put this down, it'd be like negative 3 times the negative 3 times the negative 3. But 1/3 of those would just equal a negative 3. Another way it could also be written is if we wrote it as a negative 27 to the 1/3. Notice what we did here. The 3, that's the index of the cube root, is what goes in the denominator of the fraction, right? So that would also, of course, be the same answer, it's the same thing, be negative 3. Okay, so that's if the n is an odd number. That's the first rule. If the n is an even and it's greater than 0, then a has two real nth roots, a positive and a negative. A plus or minus is what we call this sign. Okay, and again, we could write it as the roots, or we could write it as a fraction. So let's look at that real quick. So here's another example. Whoops, let's do this one. This time we have the n being even. Remember where the n goes, right here. The a goes, the radicand goes inside the 16. So if the n is 4, which makes it even, and it's also greater than 0, so 16 is going to have two answers. See, if it's even, it has two real nth roots. Okay, so we have two answers when we're going to the fourth roots, because 4 is even. So what would that be? Well, 2 to the fourth power equals 16 if we were to go forward. So going in reverse, oh, actually, it also, though, I must say a negative 2 to the fourth power also equals 16. Because a negative times a negative is a positive, times a negative is a negative, times a negative is a positive, right? We're to multiply that out. So these are both true. And so the fourth roots would have both a plus and a minus answer, right? So the answer would be plus or minus 2, because the positive 2 is the answer and a negative 2. So we'd indicate it with this symbol plus or minus. Okay. I guess you could also write it like this, though. So room on here. You could also write plus or minus 16th to the 1 over 4. Right? Which also equals plus or minus 2. Remember, this way to write it with the radical and this way of writing it with the fractions are the exact same thing. Okay. If the n is even and a equals 0, then a has one real nth root, and that's just if it's just going to be 0. So if the n is even and the a inside is 0, I think that makes sense, right? 0 times 0 is 0. And then if the n is even and it's less than 0, there's no real nth roots. And we'll talk about that a little bit more later. But those are the rules that will help you with integers. So I want you to go ahead and try this one on your own and see if you can do it. If you need to rewind the video, do so. Now we just talked about, though, that the radical of the square root of this a here, whatever it is, indicates the positive square root of a. Similarly, an nth root of a, when it's an even index, indicates a positive nth root of a. Let me show you what I mean. So looking at this one here, you're taking it to the cube root, and it's a negative a. So if we were to rewrite the expression here showing its factors, right? If we were to take this one and rewrite it, it'd be like a negative 2 times a negative 2 times a negative 2, because that would equal 2 times 2 is 4, and 4 times 2 is 8, so it'd be a negative 8. If we were to do the cube root of that, 1 out of the 3, what would equal? Negative 2. Right? That's evaluating this negative 8. And it would just be the one answer, right? Let's look at this one here. Very similar. We still have a 2 times 2 times 2 to get the 8, so we're pulling out a 2, right? We're going to pull out that 2 when we evaluate the cube root. But when we pull out the 2, notice there's a negative already there. So we have to attach the negative to it. Pull out a 2. So this answer and this answer are the same. They're both negative 2, even though they look a little different. The negative's coming from the radicand in this one, and it's coming from outside the radical on this one. Okay, let's look at this one here. Let's see. So 16th to the 1/4. Now it's writing it in as a fraction, but we remember that whatever the denominator is here, that's what goes on the index, right? So basically, that is the same thing as writing the 4th power 16. So what times what times what times what is 16? Well, that would be, if we were to write it its factors, it would just be 2 times 2 times 2 times 2. And so we're taking 1 out of the 4, right? Which is what that even says here, 1 out of the 4. So the answer would be 2. Okay. And then look, this last one's kind of interesting. It says take a negative 16 to 1 to the 4th. But that's not a real number, because there is no real number that can be multiplied by itself 4 times to produce a negative 16. Because remember, a negative times a negative is a positive. And so it's really a trick question. So it's no real number. Okay. We'll go ahead and stop here, and we'll continue next time.